Right, here we go with one of the all-time greats here, going through these important people. Some are more important than others, and Michael Faraday certainly falls into that category to my mind. Yeah, so this is the English physicist and chemist. I mean, most famous in physics for discovering electromagnetic induction, which is the foundation of pretty much all of modern life. Without electromagnetic induction, there'd be no transformers, so you wouldn't be getting the energy transfer happening in the way that it does. We wouldn't be getting electric motors. We wouldn't have dynamos. All of this stuff. I mean, obviously, someone else would have discovered it. It's not like he created the thing, but you still needed a great mind in order to work this stuff out for the first time. And Faraday was definitely that man. But I'll come back to all of that in a little bit. He was born in south of the river in London, so this is in Newington Butts, so that's near to Elephant and Castle. His family wasn't particularly well off. They'd recently moved down from the northwest of England down to London. He didn't have very much schooling. He had a little bit, but not a lot. He was mainly then self-educated. I mean, at age 14, so he was already out of the education system by age 14. He started as an apprentice bookbinder, and that gave him access to a lot of books. He also used to go to lectures and discussions at the City Philosophical Society. So he was very much a self-starter and enthusiastic about his own learning. When he was 20, he attended a lecture or a series of lectures actually by Humphrey Davy, the chemist. This is the famous chemist who he isolated a whole load of different elements for the first time, quite often using electricity in his experiments. And he also, with his use of electricity, invented the Davy lamp that was named after him. So he was like this real big cheese chemist when Faraday was young. And Faraday went along to these lectures and he made extensive notes. And then he sent this, hundreds of pages of notes to Davy, who was quite impressed by this. And it wasn't long after that Davy got injured in a lab accident, and he damaged his eyes. His eyesight wasn't that great, and he then employed Faraday as an assistant because he couldn't see so well, and do all of his own notes and record keeping and such like. So that was a real, opportunity that he'd created for himself by going to these lectures and making these notes. And then he had a foot in the door of working with one of the greatest scientists of the day. Faraday he was a devout Christian, and he met his future wife through the church. They married in 1821 when Faraday was around about 30. And this was a theme in a very modest life that Faraday had. I mean, he turned down a knighthood on religious grounds because he didn't approve of this idea of accumulating fame and riches and worldly reward. He didn't see that as compatible with his Christian beliefs. He also twice refused the presidency of the Royal Society. And then from a more ethical side, he, with his chemistry skills, he wouldn't assist the government in the production of chemical weapons, or at least looking into the production of chemical weapons for use in the Crimean War. He had a strong religious and ethical streak, and very much his life was his work. He was a master of experimental science and communication. His maths was good, but he used maybe, when I say buts, it's not really a but in it. He used more intuitive methods. He didn't have the formal mathematical training that a lot of the other scientists did of the day. So he had to focus more on the understanding and other ways of communicating these incredible things that he was working out. But to say that he wasn't skilled in mathematics would be overstating it. I mean, you can't do all of the science that he did without having that sort of some kind of grasp, even if it was unconventional, of the mathematics behind it all. his scientific discoveries, I mean, they were extensive in chemistry, which is where he started when he was working with Davy. When he discovered benzene, he was liquefying gases such as chlorine and such like. He laid out the laws of electrolysis. So he popularized terms that other people had come up with, but terms such as anode, cathode, electrode, ion, things like that. He was the first person who was really using these regularly in more public scientific discourse in his lectures and such like. And he didn't publish his lecture notes because he saw himself as being this experimentalist and this communicator. I mean, it was integral to his science. He demonstrated things. He didn't just write stuff out. He wasn't just theorizing or publishing results, although he did publish some results. But in terms of his lectures, he wasn't one for, well, here's documentation or of all the manuscripts and of my lectures. It was, well, if you want to know what his science is, you go along and you see him demonstrate it. It all went hand in hand, the experiment and the explanation. So when we then get to just after Orsted's time, as I've mentioned in quite a lot of these videos, Orsted's discovery of the deflection of a magnetic needle next to a current carrying wire. So this was really opening the door to, right, we've got a connection here between electricity and magnetism. And Davy and chums had tried to construct an electric motor off of the back of this. And they hadn't succeeded, but of course Faraday was working in the same circles. He had seen and discussed what they were doing, and Faraday succeeded in creating this electric motor. He then published these results and demonstrated this motor without crediting any of the contribution of Davy and the others, and this damaged the working relationship between Faraday and Davy. But then, I mean, Davy was much older than Faraday, and then when he died, Faraday was then working on electromagnetic induction. I mean, his big breakthrough came in the 1830s. He observed that if you had the two isolated insulated coils around an iron ring, so essentially a transformer setup, the sort of thing that we study when we look at the electromagnetic induction topic in pre-university physics. So he had these two coils wound around the iron ring. You get this iron core, and you wind coil round one side, around the other side. Then you put a current through one of them, and you'll get a blip of current, a twitch of current in the other wire. You're inducing a current in the other coil. And he noticed this. He also noticed the one where you get the coil of wire and you stick a magnet in to the wire. And then he noticed as well, you can induce the current in the wire by passing the magnet through it. So he was establishing this idea, this discovery that a changing magnetic field produces an electric field. And that was what was then causing the current to flow. But of course, the emphasis there is that you need to have a changing magnetic field. So you needed it. You were only getting the induced current when the current was switched on and off in the other coil. You're only getting the induced current when the magnet was in motion and the field was changing inside the coil. So this is then leading into Faraday's law. Faraday had described all of this stuff, but as I mentioned, he wasn't the formal mathematician of the day. So James Clerk Maxwell came along and he formulated Faraday's findings mathematically, and of course this then became Faraday's law, which is one of Maxwell's equations. Faraday then moved on from this. He discovered this idea. He'd found out about this electromagnetic induction, and then he was using that to build a dynamo, building that electric motor. I mean, this is the foundation of everything that we have nowadays for electric motors, for modern power generation, and all of that, which I cover in my videos on electromagnetic induction. he then moved from that to put more of a theoretical underpinning behind all of this. So he started describing electricity and magnetism in terms of fields extending through space. Now, people hadn't done this before. There was a lot of discussion of, well, is it some kind of substance? This was always the fallback thing, wasn't it? Like we had with when they were looking at light, was there some luminiferous ether that the light was traveling through that was permeating all of space? Was electricity some kind of substance? And Faraday was saying, well, no, these are fields that extend through space. And this got met with great resistance, and it wasn't fully accepted before Faraday died in 1867. But he did demonstrate other things that were pointing towards that. So he was really moving things along. I mean, the Faraday cage is one of those things. This is where you go inside a charged cage and show that there is no electricity inside the cage. Because if you've got a charged conductor, the charge spreads out over the surface, and it spreads out so that the electric field inside the charged conductor is then zero. All of those fields cancel out. So if you're inside it, then it's fine. This is why this is how Van de Graaff generators and such like work. You have these hollow metal globes, and inside you can build up loads and loads of charge all over the outside of the globe, but inside you've got no electric field. So the fact that he could go and stand inside these Faraday cages, which have been charged up to the max, and he's standing in there, well, it was, this is demonstrating against this idea that you've got some kind of substance flowing around with all this electric charge. It's pointing towards these forces and how those forces are just cancelling out inside the cage. So yeah, I mean, he was really making loads and loads of breakthroughs. I mean, this is why you move on to the next century and you've got Einstein. I mean, himself one of the the absolute paradigm shifting greats of science. And Einstein, he had 3 portraits on his wall in his study. He had Newton, Faraday, and Maxwell. That's how significant he saw Faraday to be. I mean, he really was pushing the boundaries to an enormous extent. And that's why, I mean, he's got the unit of capacitance. That's the unit that's named after him, the Farad unit of capacitance. He died at home he lived in Hampton Court. So, the little town of village of Hampton Court, as it probably was back then. So, not in the palace, but in a house in Hampton Court. He was 75. He was buried in Highgate Cemetery, and again, his sort of modest lifestyle gets shown again. He was offered before he died burial at Westminster Abbey, but he turned it down. I mean, there is a memorial to him in Westminster Abbey near to Newton's tomb, but he was buried at Highgate Cemetery in the non-Anglican section, I believe. So although he was a devout Christian, he wasn't an Anglican. So he was in some kind of offshoot of the Church of Scotland. But I can't remember exactly what denomination it was now. But yeah, there you go. I mean, Faraday, a very interesting life, extremely adept at communicating and experiments, and just discovered so much that, as I say, underpins everything in life today. This is the real transformational stuff in 19th century physics.